Hi, hello everybody. So this is the second video dealing with section or topic 8.1, solving quadratic equations by completing the square. In the first video, I've covered the first step, which is solving by using the square root property. We've covered these three examples. So now that we know how to apply the square root property, we'll take a look at solving quadratic equations by completing the square. So normally, when we're solving by completing the square, the equations are not going to be in the form as you see here in section 8.1a. They're going to be in regular standard form, which is this form right here, ax squared plus bx plus c. And our goal is to turn this form into something that looks like this, because then we can apply the square root property as we did before. And the process of converting the standard quadratic equation into this format is called completing the square. And I'm going to show you exactly how to do it. So it's easier to show you visually than verbally describe it. But we are going to begin this process with the standard equation as you see here. So we're going to have the equation in ax squared plus bx plus c equals 0 form, and then we're going to go from there. So let's take a look at the first one, x squared plus 8x minus 10. And I already copied the problem over here. So this is our beginning step, right? So the equation has to be equal to 0. So the first step into solving by completing the square is that the number, or the c, right? So ax squared plus bx plus c equals 0. This is the standard form. This number has to go to the other side. So in order to do that, I will add 10 to both sides. Now on the left, it'll cancel. And it'll show up on the right with the opposite sign. So this is step one. So move C to the right. The second step is we have to turn the left side, make left into x plus k squared, where k equals b over 2. This is a number that we need to find. This number is going to be whatever the b coefficient is divided by 2. Here is the b coefficient. So let's take a look at this example. I need to end up with this on the left. So parentheses, the variable is x, so you're going to write x here. Whatever this sign is, you're going to put it over here. And this is my b. But in here, I need half of this, right? According to my formula over here, b over 2. 8 over 2, 4. And here's my square, equals 10. Okay, so this is the second part. Still in the same process, still step 2, we are going to adjust the right side. Okay, this is called completing the square. The adjustment is always going to have a plus sign here. This plus sign has nothing to do with this plus sign. This is always plus. And what you're going to write over here is going to be this, 4 squared. Okay, so let me just rewrite it. X plus 4 squared equals 10 plus 4 squared, 60. This step is called completing the square. Now that we're here, notice that this is identical to the problem before. All I have to do is apply the square root property now. When I do, I get x plus 4 on the left. Don't forget plus or minus. And in this case, I cannot simplify radical 26, so it's just radical 26. Finally, I subtract 4 from both sides, and I end up with minus 4 plus or minus radical 26. And this is my final answer. Okay, so to recap, we'll do another couple problems. We begin with the standard form. We move the number to the right. Then on the left, this has to turn into this over here, where this k number is your b over 2. So x, whatever the sign is, in this case it's plus, half of 8 square, and then you do the adjustment, which is always plus for whatever this number is, square. And from here down, we apply the square root property as in the previous video. Okay, so that was the first example. Let's take a look at the second example. So here's the second example, x squared plus 10x plus 5. So again, solve by completing the square. X squared plus 10x plus 5 equals 0. And we just confirm that this is the exact same problem. Okay, so we are in standard form, ax squared plus bx plus c. The very first thing I need to do is move this to the other side, and I'm going to do that by subtracting 5 from both sides. Right, that's my step 1. Step 2 is this left side needs to look like x plus k squared, where this is b over 2. X plus 5 squared, half of 10, equals -5. And now I have to do the adjustment. The adjustment is always plus whatever this is. 5 squared, 25. Okay, so we converted the x squared plus 10x. This is the complete the square process. Variable x, same sign. Half of this square equals whatever number is here, plus the adjustment, which is this number square. So x plus 5 square equals 25 minus 520. At this point, I am ready to apply the square root property. The root property is just taking the square of both sides. X plus 5 equals plus or minus, and I need to simplify this, which we already know that I am going to write it as radical 4, radical 5, and this is 2. Okay, 4 times 5 is 20. Square root of 4 is 2, radical 5. So that goes over here. We already saw this example before. And as my final step, I will subtract 5 on both sides. So then my final answer is x equals -5 plus or minus 2 radical 5. Do not combine the -5 and the negative plus or minus 2 here because the 2 is multiplying the square root of 5. This is my final answer as it is. Okay. Now let's see one additional example. 2x squared minus 12x plus 24. Solve by completing the square. 2x squared minus 12x minus 24. We'll check to see, make sure that I didn't copy this thing wrong. Minus 12x plus 24. Plus 24. So this is a unique case because there is a 2 here. And my procedure requires me to start this with a 1. So notice that every single coefficient is divisible by 2. So I'm going to divide this by 2. I'm going to divide everything by 2. So I will end up with x squared minus 6x plus 12 equals 0. This is the starting point. This is the starting point. I have to have a 1x squared here. Now I can proceed and I know what to do. This number has to go to the other side. I will subtract 12 on both sides. When I do, this becomes 0 and I get the minus 12 on the right. Now, the left side has to be rewritten so that it becomes x minus k squared, where k is b over 2. This is my b. So this will be x minus, notice, whatever sign this is, it gets carried over here. Half of 6 squared equals negative 12. After this, I have to adjust. The adjustment is always plus, regardless of what this sign is. And the adjustment is this sign, this number squared. Doesn't matter minus or positive, square, it's always positive. So 3 squared is 9. That is my adjustment. So I will end up with x minus 3 squared equals minus 12 plus 9, negative 3. Okay, so far so good. At this point, I am ready to do the square root property, which is just taking the square root. Okay. So I will go over here. This square will cancel with the radical. I do not forget, I end up with the plus or minus on the right. And then I have this weird thing, negative radical 3, square root of negative 3. But remember, when we have a minus here, I have to introduce imaginary numbers. So 3 is going to become 3 times minus 1. The minus 1 is going to be changed to I squared. And then I can simplify this. This is radical 3 times radical I squared, and this is just I. So this is radical 3 times I, and we always leave the radical last, so you're going to write it as I radical 3. So this factor has to be changed to this, according to our section 7.7. So I'm going to rewrite this, x minus 3 plus or minus I radical 3. And now I'm ready for my final solution by adding 3 to both sides. These will cancel. I have 3 plus or minus I radical 3. Okay, so this is a good problem. It is unlikely that you might see on our exams or final exam a number here, but if you do, you want to be sure to divide everything, in this case by 2, to begin with a 1 before you complete the square. The remaining steps are the same. You move the number C to the right. You turn in x squared minus 6x into this format, because I have it over there, x plus or minus k squared, where the k factor is b over 2. You do the adjustment in red. The adjustment is always this number squared, as I have it over here. Once you have x minus k squared on the left, you will apply the square root property. The 2 will cancel with the radical. You will have plus or minus, and then you will simplify whatever radical you have on the right, if it is possible. Remember, we saw cases before where we had radical 15. You cannot simplify that. But in this case, you can also do some simplification, but the radical 3 remains the same. But the minus needed to be changed to I squared, and the square root of I squared becomes I. So that is required. So for this particular problem, this is the answer after I add 3 to both sides to isolate my variable x. So this is the process of completing the square. Both versions in the video on the topic 4, either the application of the square root property for these 3 problems, or the second application are included in the process of completing the square. So first we need to know how to apply the square root property. So this was the first video. And then we apply the square root property and the completing the square technique to solve these quadratic equations.